Hey, what's up YouTube? Welcome to another Moralis tutorial video. NFTs are the standard for assets you want to trade with because they have its own price, they are unique, and you can use them for digital art, physical assets like house deeds, and more. But what happens when you need the same concept of uniqueness and immutability you have with the NFTs and you want to have tokens that are not tradable? That's why today we are going to give a look into a new token standard called the ERC 4671, the non-tradable token standard, which has a lot of similarities with the NFT token standard, but for different use cases. So basically, a non-tradable token on NTT represents inherently personal possession, such university diplomas, online training certificates, government-issued documents, national ID, driving licenses, visas, weddings, etc. Assets that are not only unique, but are related to you as a person, or in this case, to your wallet. Because this is information you are not going to trade with. You're not going to trade with your national ID or your driving license, because it's yours and just yours. On today's tutorial, we are going to learn how to implement this new token standard, create our own certificates as we were at university, giving certificates to students, and also we are going to use Moralis endpoints to create the token URI. So if you want to learn how to accomplish this, keep watching because we are just getting started. What's up YouTube, my name is Vasily, your Web3 instructor from Latin America, Ecuador. I've been building on the space since 2020 with cool crypto projects. In my free time I really enjoy singing and playing the guitar, and if the time is good, I like to go out and take some meditations. But enough about me, let's go back to the video and start building. So the key aspects of a non-tradable token is that it's actually pretty similar to the NFTs, but in this case, once the token is minted, the owner address of that token is not going to be able to trade, commercialize, or sell that token. As Vitalik Buterin would say, they are going to be soulbound tokens. However, the authority who delivers the certificate should be in position to revoke it. For example, you discover that a student cheated on an exam or on a test, then the institution would have the authority to revoke the access to that certificate. However, the token cannot be deleted. And the most typical usage for third parties will be to verify if a user has a valid token in a given contract. So if you have a certificate on a university, you can then travel to another country, and then on that country you would be able to verify if that certificate actually belongs to you. So these are the key aspects in this EIP with the most important functions for this standard: minted, revoked, balance of, owner of, is valid, and has valid. And also it has some extensions, so you will be able to add metadata such as the token URI, on which you are going to have like the information, maybe the image of the certificate or some relevant information such as what was the institution which created the certificate, and etc. Also we can have enumerable, which is also pretty standard for NFTs. We can delegate the rights of the token minting. For example, the sysadmin of a university creates the contract, but then delegate the token minting to a professor or someone on the university. Also, we can have consensus. For example, if a student is giving their final defense for their degree, the teachers will have to reach consensus in order to mint or not the specific NTT. And well, we also have another extensions you might add to this token standard. Of course, the metadata is going to be kept outside of the blockchain, not just because it's more cheaper, but also because entities are meant for personal possessions, so it's not good by any means to have that personal information on the blockchain. Now, if we want to implement this token standard, which as you are going to see soon, is pretty similar to an NFT, besides the non-ability to trade this and the extensions I just showed you, we can start implementing one by one all of these functions. But fortunately, we have a reference implementation over here. So if we click here, this is going to open a GitHub page on which we have all the contracts we are going to be using for this implementation. We are not going to use them all, but anyways, I'm going to just copy and paste each one of these contracts, copying its name and its information, and use it on my Brownie project. And here we are. I am on my Brownie project. I have copied all the contracts from the GitHub, including the interfaces, and now we can create a new certificate. Remember that same as the NFTs, they have this interface for the metadata on which you can override the functionality for the token URI and also create a new function to set it. So let's do that. On the ERC 4671, let's do that. First, we are going to start creating a new mapping for the token URI, which is going to map a uint 256 to a string. It's going to be called token URIs. Here on the token URI function, we are going to change it to first verify if the token exists, if not revert the transaction, and then add that to that mapping. And of course, return the token URI. Finally, we are going to create a new function to set that token URI. So let's say function set token URI is going to receive the token ID and the token URI, which is going to be a string. Of course, only the creator is going to be able to set that. And finally, we are going to use that mapping to set that token URI for the specific token ID. Once we have all this previous setup, let's create our actual main contract. So this is going to be called certificates.sol. Let's get started by adding the license and the Solidity version. Then we are going to import that token standard from the local contracts. Also, we are going to use OpenZeppelin standards just to make this contract ownable in order to use that only owner functions. And then let's declare that contract. Contract certificate is ERC 4671 and is going to be also be ownable. Now the compiler is going to be mad at me because this ERC 4671 requires a constructor parameter over here on which we have to provide the name and the symbol, same as we do with NFTs. So in this case, we are going to say on the constructor, I'm going to send you over string memory course name and string memory token. Now we can use that constructor for the ERC 4671 and send over that information. And as easy as that, the compiler is happy with us because we are fulfilling all the constructor needs. Now let's add basic functionality to this contract. So let's first create a mapping to map from the student address to the token ID. So let's create also an event for good practices. So this event is going to be triggered each time we create a new certificate. So token minted, and it's going to have an address with the owner of this new certificate and the token ID. Now let's create a new function to mint that token. So mint a token for a specific address. Function create certificate is going to take as parameters the address of the student and the token URI. This is going to be a public function, but it's going to be only owner. It means just the contract creator could use this. Let's mint the token for the student. Now let's add that token to the mapping we created. So student to ID, sending over the student, and let's use the immediate count -1. And the reason is because the token count is going to start at 0. So once we mint, that token counter is going to be 1, but the actual ID for the first token minted is going to be the actual number -1. Now we can use that set token URI function. So set token URI function, sending over the ID and the token URI, and the ID now it's going to come from this mapping again. The token URI is the one we are sending over as parameter. As always, as good practice, let's emit that event we just created. And as easy as that, we have all we need to start minting our new entity tokens. However, we are going to add a small extra functionality here on the ERC 4671, and is the ability to get all the tokens for a specific address. Because if you check the contract, you're going to be able to have these functions such as token owner by index, the balance of an address, which is using this mapping indexed token IDs, but is taking the length. But in this case, we want to get all the IDs related to an entity a specific wallet has. So in this case, let's create that. First of all, let's add standard comments for Solidity. And now let's say function tokens of owner. Here we are going to send over the owner of the contract. This is going to be a public view virtual function which returns an array of the tokens. And we are going to return all the indexed token IDs for the owner we are sending as parameter. And if you wonder what this indexed token IDs is, you can just check this out, and is a mapping which maps the owner to the token IDs, which is kind of the same we are using over here. So let's save all of this and compile our project. So let's say brownie compile. Now we have all the contracts we need. I'm going to deploy this on the Polygon Mumbai testnet. So let's create a deployment script. For that, on the scripts folder, I just have here a script called helpful scripts, which is going to give me the information of the account based on the context. For example, if I'm providing the index, is going to give me the accounts which comes from Ganache, or if I'm not providing anything, it's going to take that from the configuration file, and in this case on my brownie configuration I'm getting that from a private key which is stored on my .m file. So let's deploy that certificate over here. Let's say from brownie import me the certificate, and from scripts.helpful scripts import me that get account function. So let's say def deploy certificate. Let's say account equals to get account, the name going to be equals to Moralis certificate, and the symbol is going to be equal to MOCRT, for example. Now let's say certificate equals to certificate.deploy. Let's send over the name and the symbol. Of course, we need to sign this transaction from our account. Let's print here the certificate.address, and let's return the certificate. Now we just have to create a main functionality to deploy that. And as easy as that, we have all we need to deploy this contract. So let's give it a try. Let's go back to my terminal and say brownie run scripts deploy certificate for the Polygon test network. This is going to trigger the transaction. And here we have the address of the new deployed contract. If we check this out on the Polygon scan for Mumbai, then we have the contract is actually deployed. So now we have to mint new certificates and get the information out of them. So let's do that. So for that purpose, I have here another script called mint and get. So let's use that recently deployed certificate and get the information out of it, and start minting new certificates and also get the information out of them. So as same as we did before, let's first import the certificate and the helpful scripts. Now let's create a new function, mint new certificate. Here we are going to declare the account. It's going to be equal to get account. The certificate is going to be the certificate -1, which is going to go to the build folder on deployments. It's going to take, based on this map, the latest deployment, in this case for the Polygon Mumbai network. Now we can say that the token URI is going to be something over here. Now, this is the part that things get interesting, because we have now the contract and the ability to start minting new tokens, but the information of that token is going to be stored on the token URI, because for now, even though we have all these contracts, the only thing we are going to actually have is the identifier. It means the token ID related to an account, and that's all. It's in the token URI where we are going to store the actual information. And again, remember, as storing information on the blockchain is really expensive, this standard suggests us to use external metadata, including the another reason that these are for personal possessions. So now we have to use something like IPFS to store the image of the actual certificate, and also to store the token URI, which is going to come as a JSON. And for that matter, we are going to use one of Moralis endpoints. We are going to use the IPFS API. We can just follow up the instructions on the official Moralis page, but at the end, if we go to the API reference and to the IPFS API, we can look that the only parameters we need over here is to set up the path of the image and the content, which is going to be the image itself. This content is meant to be a bytes 64th string, so we have to transform the images we are going to use. So before we start minting, let's create a token URIs using Moralis. So here in my project, I'm going to create a new folder called upload to IPFS. Here I'm going to create another .m file to store the Moralis API key, and I'm going to have two scripts. first of all, the script to upload the images, and the second one to create the token URIs. So IPFS upload.py. And of course, I need to have another folder over here called image. And here I'm going to store all the images I'm going to use. So I have here 3 template images for the certificates. This is going to be the ones I'm going to upload to IPFS. Remember that if we are talking about a real enterprise, a real institution minting these certificates, they must have the actual image with the name and the date for the student earning that certificate. So now, let's do this quick. First of all, as we are going to use Moralis, don't forget you must go to your terminal and use pip install Moralis. I already have it. So I can first import Moralis. Secondly, I'm going to import the load.env to get the information of the .env file with my Moralis key. And also, I'm going to make some imports in order to be able to get that private key. And these ones are for me to be able to transform the image to a base 64 as the Moralis endpoint requires. Of course, I'm using this load.env to load that private key. Let's declare first a folder path, which is going to be this image path. And now let's declare the Moralis API key. Again, this is going to be stored here on the .env file. Now, if you don't have a Moralis account yet, this is the part of the video for you to hit pause, go to moralis.io, create your free account, and here on your admin panel, you are going to have the access to your free API key, which is really useful for NFTs, all the transactions on EVM blockchains, the Streams API, the Authentication API, and the Solana API. This free access is really good for basic petition or for testing purposes, but if you're working with a big NFT collection or marketplace, step up your blockchain game with Moralis Pro. With twice the computing power and more requests, you can handle even the most demanding projects. Plus, enjoy unlimited daily records on your streams with automatic retries for a seamless experience. And with more replays and longer retention for your historic streams, you'll never miss a beat. Don't settle for basic, upgrade to Moralis Pro today and take your projects to the next level. So once you have this API key, don't forget to copy it, go back to your .env file and paste it over there. Remember, this is sensitive information, so please do not share your API key with anyone. Now I'm going to add a really simple script over here, which I'm going to explain to you. This function is going to be to upload the images. So I'm creating an array of images and I'm looping through all the images on the image folder, transform them into a base 64 image, and then calling the Moralis endpoint upload folder, which is going to use that API key, and the body is going to contain the path and the content, such as the Moralis endpoint required us. Also remember that if you get lost understanding how to use this, you can just go to the Moralis documentation under the IPFS API and follow the instructions on which you're going to have a step-by-step guide. At the end, I'm doing exactly the same, but I'm just looping through this image folder to create a new link for each one of these images. So in order to test this out, let's invoke that function upload images. Let's save this, go back to the terminal, run this, and as easy as that, we have 3 different endpoints. So for example, if I copy this one, go back to my browser and paste it over here, as you can see here, I have the image which is stored on IPFS through Moralis. Now we have the 3 images we are going to need. So let's create now the metadata for those and create those token URIs. So on the script IPFS upload, I'm going to do kind of the same. We need to import Moralis, JSON, base64, OS, and also that script from here. Don't forget to delete this. And now we can say the API key is going to be again the one stored on the .env file. I'm going to set up 3 names. In this case, I'm just going to put some generic information. You can personalize this as much as you want. I'm going to set the descriptions, again, generic information. You can then clone the repo related to this video and personalize it as much as you liked. Now I'm going to get the images, so I'm going to trigger that upload images function, print that, and I'm going to have 3 different variables over here for the assignment, the specialization, and the institution. Now let's create a new function called getUpload metadata. Again, as we did before, we need an empty array. And here I'm going to, again, loop through that images I'm getting from the IPFS URLs. So now I'm going to create a new for loop on which I'm going to create a new dictionary, getting the name, the description, the image, and the attributes for each one of these URLs. And now we can create that body requested by the Moralis endpoint. The path is going to be metadata.json. Again, we are going to encode that to a base 64 string using all this content over here. Then we can declare the result. The result is going to call that endpoint ipfs.upload folder, sending over the API key and the body. And finally, we are going to append each one of those token URIs to this IPFS metadata we declared. Now I'm going to add some extra functionality just to create a new file called IPFS addresses on which I'm going to store all those token URIs. Let's create a new file called ipfs address.json and dump all that information. Again, if you get lost with this explanation, don't worry, all the code for this lesson is going to be on the video description. Let's test this out. So Python ipfs upload.py. This is going to trigger all the same information as before. And now we are going to have this metadata.json. So if we go to this IPFS addresses JSON, save this, we are going to have all the metadatas. So for example, if I take the first one, let's copy this, go back to my browser, open this in a new tab, and here we have the certificate number, the description, the image, which we already know is the same as before, and these attributes. This is all the token URI information we are going to use on our NTT. Now we have the token URIs, so we can just copy this over here, go back to the mint and get script and create a new one here called URI. So now we can use those token URIs here on this variable. And as this is a tutorial, let's just select one of those randomly. So let's import random from Python and let's say random.choice from the URIs. Now we can say certificate.create certificate, which is the function on our smart contract over here, create certificate, and let's send over, which is going to be the owner of this. On this case, let's make the owner the same account, which is minting this. So account.address, let's set over the token URI. And of course, we need to sign that transaction using our account. Now let's just print that the certificate was minted successfully. Let's declare a main function. So let's say brownie run scripts mint and get.py on the network Mumbai or the Polygon testnet, which is the same. Let's hit enter. We successfully minted the new NTT certificate on this address. So now let's create a function to get that. So here I'm going to say def get NTTs. This is going to use again the certificate. The account is going to be the same account. The entities are going to be equal to certificate.token of owner for the account.address. Remember, this tokens of owner is the function we created here to get all the IDs a wallet has. Now let's say for element in entities and let's print some information over here. So for example, let's print the certificate URI, the owner, and the token ID. Now let's run this get entities and let's run this script again and see if this works properly. So let's go to the terminal, run again this script. This is going to mint a new entity and now we are getting the information of those. And as you can see here, we have the address of the new certificate minted and the token URI, which, as you already know, contain all the information of the metadata of that certificate. So, as you saw, this standard works pretty similar as you will expect from an NFT, but with the difference that you cannot trade that tokens with anyone because they are for personal information, and also that the minter address is going to be able to revoke the access to that entity. And that was it for today's video. We hope you enjoyed this tutorial. Please don't forget to subscribe to Moralis channel, and I'll see you on the next occasion. See ya!